Here we are, session 9. We're going to take our soils to the doctor. We wanted to share with you about soil health assessment, some of what's out there. So next slide. So in a nutshell, you've seen this slide, right? The idea is that one of the places where you all can have an impact is to improve awareness of soil health and what the benefits and practices, the benefits and opportunities are of maintaining healthier soils. And one of the first steps in that when you're looking at a degraded soil is to understand and diagnose what those constraints are and what those resource concerns are. And we need that to go beyond nutrient limitations and excesses. When you understand what the problem is, you can actually fix it, right? It's like taking a human to the doctor. If you've got COVID, then a cast isn't going to do you any good. If you've got a broken leg, then ibuprofen might do you a little bit of good, but really you probably need a cast, right? So we need to target our management at the actual issue at hand, and that's a lot of what soil health assessment was designed for. All of that, of course, is to basically assess, well, where's the habitat and the feed source for your livestock at, right? Are we actually taking care of those underground livestock? Next slide. So I'm going to tell you a short story here. This is from work that I did back in 2012-ish. I was meeting up with Doran Cox. Some of you may know him. He's now the lead on Open Team and is doing some really great stuff in terms of making the software space a better space for farmers. But one of the places we started was on his very own farm. We were looking at his soils with the Cornell Soil Health Assessment that I helped develop while I was a grad student, and then continued to build further movements on. And we were looking at a soil on his farm that was a Buxton silt loam and a soil on a different farm that was maybe 10 minutes down the road, same Buxton silt loam soil type. But you can see just looking at the pictures that there's a big difference here. The soil on the right at this conventional vegetable farm had been in constant, basically tillage multiple times a year, no cover crops, no manure inputs, no compost inputs, a lot of tillage. They had been growing strawberries. Strawberries were not growing anymore. Then they were growing sweet corn. That wasn't working anymore. And they were at wit's end, really not knowing what to do with these soils. Meanwhile, same soil type, Buxton silt loam on Doran's farm was very productive. They're an organic mixed operation. They grow vegetables, they have perennial crops, they graze, they grow some small grains. So very different management. When we did a standard soil test, the soil on the right was the one that showed up with no constraints. The pH was right, all the nutrients were right. On Doran's farm, the pH was a little low and needed more potassium. I think it needed a little more phosphorus. When we did the soil health test, that's where we really saw the difference, where on Doran's farm, things were pretty much in good shape. There were a few tweaks we needed to make, but everything biological and physical was off on this other farm that was the conventional farm. So I say that just as an insight on how these kinds of tests can be really effective at identifying what the constraints are. Next slide. So we talked about this downward spiral. I'm not going to go back into it, but just wanted to share this again to say, this is what we're trying to get at, right? What exactly are the functional constraints that soil is experiencing? What is it that we're, what aspects of the soil are degraded? Are we seeing crusting? Are we seeing compaction? Are we seeing poor infiltration? Are we seeing poor biological activity, poor aggregate stability? All of these things are things we can actually observe in the field and can at times measure in the lab. Next slide. There are many reasons for soil health assessment. One of them is basically take our soils to the doctor, right? To kind of understand those constraints and then target practices. But also soil health assessments can be used to measure improvement or degradation over time. So to really kind of monitor what's going on with soils. So if you're thinking about something like an easement where it's going to be in agriculture, one really good idea might be to do a baseline assessment of soil health, get all these measures, and then come back 5 years later, 10 years later, 15 years later to see how that soil is faring and whether things are moving up or down. A lot of these assessments are used for applied research. They can be really great for improving awareness, especially some of the qualitative indicators we'll talk about. There's talk of enabling valuation of land so that better soil health is actually valued when you sell land. You can assess system risk, and there are also potential opportunities for integrating that into policy recommendations. So lots of opportunities. Next. So that analogy of human health versus healthy soils, right? There's some similarities here. There are inherent properties, right? Every human being comes into the world with certain genetics. That's something we can't really do anything about. Every soil comes into the world with a certain texture, certain mineralogy, certain depth, certain climate. That's not something we can do something about. But then there's how we manage that health. So for the more dynamic properties for humans, weight, heart rate, blood pressure, for soils, organic matter, aggregate stability, bulk density, right? Environmental factors, there's management factors, there's indicators we can use to measure, right? So we might measure cholesterol for a human being as an indicator. And for soil, we might measure soil respiration, infiltration rate, aggregate stability, and so on. Next slide. So there are both qualitative and quantitative assessments. And the idea there is basically a qualitative assessment is something you can just quickly ascertain in the field. You go in the field, you look at a certain thing, and you have an idea. Is it bad? Is it good, right? Quantitative, you send the sample off to the lab and you get a number back, and you have to have a good interpretation for that number for that to really be meaningful. Next slide. So when we're talking about indicators and assessing soil health with indicators, what that means is that we pick an indicator that's an assessment of a soil property and what that means about the functional status of that soil. Are the soil processes that are supposed to be working, are they actually working? So an in-field assessment can give you really good qualitative or semi-quantitative information. It is usually very rapid. It can lead to instant conversation. It's a really great demonstration tool. It's used by NRCS, by conservation planners who go out and assess resource concerns. And it's basically a way to go in the field and get some quick information right away. And then laboratory assessments, of course, take a little longer. They take a careful sample, they take sending that to a lab and waiting for the number to come back. And those are really good for carrying on a longer term conversation with a farmer for monitoring purposes and that kind of thing. Next slide. NRCS Soil Health Resource Concerns is basically how the agency thinks of that approach of taking the ecosystem to the doctor, really. So a resource concern is an existing or expected degradation. So either it is an issue right now, or we see that it really could become an issue for soil, water, air, plant, and animal resources. So the agency has a lot of resource concerns, and there are particular ones that are sort of the declared soil health resource concerns: aggregate instability, soil organism habitat loss or degradation, organic matter depletion and compaction. And so NRCS assesses for those resource concerns, and that's basically the mechanism to document the problem and to then be able to pay a farmer, if they qualify, to actually alleviate that concern and to put in place a practice that will be better for conservation. Next slide. So we designed, while I was there, a cropland infield soil health assessment where we basically pooled from across the agency, all of the states, everything that states were doing at that point to try to get at soil health problems, because there wasn't really anything in place. And we basically built that cropland infield soil health assessment to be able to address important indicators in a very quick way in the field, in a way where a conservation planner can go out there with a little bit of training and actually assess those concerns. That assessment is out there. I have links in the slide set, so when Beth shares that with you all, you'll be able to access that. I'm not going to go in depth on that because we're training on grazing here today, but I did give a presentation on the cropland infield assessment and also more on the laboratory assessments for some of the other trainings that we've done, and you'll be able to find those online, and there's a link down below on this slide as well. So if you're interested in more about cropland, you can find that information there. Next slide. I wanted to say a few words about quantitative testing. It's something that I've done a lot of work with, building the first publicly available soil health testing service at Cornell University back in the early 2000s. We were still in the space where soil health was very much in the research realm, and we were just starting to pull it into the farmer service realm to really make it available to farmers to assess their soils for biological and physical constraints instead of just nutrient constraints. And so back in 2006, we put the first assessment out. It was mostly New York based. We were offering it a little bit broader to New England and sort of the Northeast. And then as it became more broadly used, it was very much acknowledged that the interpretations were not adapted for that. Then while I was at USDA, we did a fair bit of work trying to get the community around soil health testing together to try to come up with criteria like that these tests needed to be standardized and agronomically relevant and cheap enough to measure and represent these diverse processes so that they could be used for this take them to the doctor approach and address these constraints. And so we published a technical note. We got it to the point where we had a conservation evaluation and monitoring activity, or soil health testing, that I believe is still available now to do some cost share on. And then also in the meantime, there's been a lot of other folks working on this. Soil Health Institute made some recommendations for a reduced more minimum data set of indicators. That's really good for when you're trying to save money and get a lot of assessments out across a lot of farmers. But the more, of course, you shrink your assessment, the more you're going to miss certain constraints. So if you take out an indicator, that means, if you're no longer measuring whether somebody has a broken bone, you can't tell whether they have a broken bone. And so there's that trade-off of, do you do a smaller assessment on more farms to get a broader idea, or do you really do something comprehensive for a farm where you're trying to tackle a constraint? And those two are different uses. So when you're thinking about assessing soil health, you want to make sure that the assessment you choose is a valid one for the idea that you have in mind, the goals that you have in mind. Next slide. And again, what do you do with the assessment, right? You have an indicator, like for example, aggregate stability. And if it's low, it means you need to rebuild those aggregates. You need to rebuild the biota. And so you might add fresh organic materials in the short term. You might reduce tillage in the long term. Next slide. At this point, NRCS has various different aspects of soil health testing, management planning, and design and implementation that there is cost share available for. So it's a little bit different in each state, but the links that I provided on this slide are a place you can go for the latest on what's available from NRCS for all of those aspects. So a lot more resources now than there were 10 years ago, and there's still work being done on that. And there's more work being done in the grazing space. So I think that was my last slide. So Stan, I think I'm handing over to you here. There you go.
All right. Can you hear me? All right. I'm going to keep talking.
Yes,
I didn't
we
hear
can hear you.
Oh, all right. Great.
Good.
Just wanted to check. So I'm just going to continue on kind of with that human health, soil health analogy just a little bit. About 40 years ago, yeah, it was 40. I completed the training for to be an EMT, and something just kind of clicked in my head that there's another kind of comparison here between that and when you're doing a initial assessment and treatment out on soil. So if any of you are familiar with that, when I took the training, it was ABC. You want to check for airway, breathing, and then circulation. And then I looked this up online, and there's a paper that's linked in the notes, slide notes there, but they've also gone on and added disability and exposure. So, when I relating this back to those soil health related resource concerns that Bianca just mentioned, I think of aggregate stability as kind of coinciding with airway. If your aggregate stability is shut down, there's nothing going in or out of that soil. And so, there's kind of a correlation there. The breathing and circulation kind of, in my mind, relate to that soil organism habitat. And if that's really, in my mind, all about air and water movement. And if you're not, if you're not doing that, then the soil is going to suffer pretty rapidly. And so, and then you take it further, the disability is really about their responsiveness. And so either it's AVPU, alert responsive, voice responsive, pain responsive, or unresponsive. And as I remember my training back 40 years ago, this was something we did right when you first started, before you even looked at the airway, as you kind of check their responsiveness. But maybe this is the better way to go now. Anyway, and then exposure is kind of, then you're looking at the soil more, the person more in depth, the soil more in depth, and you're looking for organic matter and what I correlate to broken bones, compaction. So just kind of, I thought there was kind of a neat analogy there, and it reminded me of that training that I took so many years ago. So we're going to focus on range and pasture in-field assessments. And within USDA NRCS right now, there's field assessments on range and pasture that continue to be integral part of our planning process and our national resource inventory studies. And the science and the tools of assessing both range and pasture continue to evolve, but we have some pretty good tools that are in place that we use for doing this. So on rangeland, the one that we look at is what we call interpreting indicators of rangeland health. It was designed to provide evaluations of 3 ecosystem attributes. That's soil and site stability, hydrologic function, and biotic integrity. So overall, this assessment evaluates how well the ecological processes are functioning. So if you think about water cycle, energy flow, and nutrient cycling, that's kind of the key ones. But again, it gets into the hydrologic function and biotic integrity and all of that as well. On the pasture side, there's 2 pasture assessment tools that are available in NRCS. They're both these tools can be qualitative and semi-quantitative, just like the interpreting indicators of rangeland health. The first one that's been around for quite a while is pasture condition score. It was first released in 2001 and was updated in 2018 with more soil health related factors. And then this next one just came out in 2020, and that's the determining indicators of pasture health. And that one is kind of patterned after the interpreting indicators of rangeland health. That has those 3 attributes that all the indicators kind of link back to. So you're really rating those 3 attributes, but you have to look at the indicators as you rate those. So just comparison across the board between those 3 I just mentioned, as well as the Cropland Infield Soil Health Assessment. And these are just the soil health related indicators. If you look at the chart there, sheet and rill is on 3 of the 4, wind erosion on 3 of the 4, stream bank shoreline on 2 of the 4, gully erosion on 3 of the 4, water flow patterns on determining indicators of pasture health and interpreting indicators of rangeland health. Bare ground, I kind of relate to cover on the cropland one. Surface crust kind of goes back to that soil surface loss and degradation. Biopores is only on the cropland one. But then as we get down a little further, compaction basically is on all 4. Roots on 2 of them. Soil color is on 3. Soil life is on 2 of them. Resistance to erosion, that's aggregate stability. That's on interpreting indicators of rangeland health and the cropland infield assessment. Soil surface loss or degradation, which relates to structure and color, those are on 3 of the 4. And then infiltration is on 3 of the 4. So when you look at this, thinking back to those 4 resource concerns, starting with aggregate instability, and then going on to that soil organism habitat loss or degradation, which to me, infiltration is one of the best quick, easy measures of that resource concern. And then soil surface loss or degradation relates to color and structure, which ties back to that organic matter and how much organic matter do you have in that soil surface and how deep is it going. And so that's those 2 factors. And then the last one is compaction. And so there's a commonality between a lot of these assessments. So that's what I'm going to focus on. And in addition to that, the interpreting indicators of rangeland health uses a reference sheet. And so you can go to that reference sheet, and all of those indicators have specific values for every ecological site that's identified out there, which is tied to the soil components. So again, here's your 4 soil health related resource concerns. And, that's really good, but how do we go about assessing these? So that's what I want to jump into now. So looking at aggregate instability, when it comes to grasslands, there's a couple different methods that are pretty common. The Hornada experimental range soil stability test kit. That's a more recent rendition of the old soil quality test kit slake test. And so basically you take soil peds, you put them in these little sample containers there, you dip them in water, and then you measure how much the aggregates stay intact. But there's also kind of a quicker test, and that's you've kind of seen a picture of this already, but the bottle cap test is also described and laid out in the Interpreting Indicators of Rangeland Health guide as a way of quickly doing a test on aggregate stability. Not quite as quantitative, but still a really good test. So that's how you kind of get at aggregate instability. Looking at soil organism habitat loss or degradation. Like I said, in my mind, infiltration is one of the best measures. It looks at a lot of different things, porosity, structure, the profile, aggregate stability, and it's looking at how that water and air movement is working in that soil. So it's a good test. It's a pretty quick test. Depends on how long it takes your water to soak in, but and we've done some additional work in South Dakota with hundreds of samples, and we've seen that it's highly correlated with plant community and management. And I mentioned that yesterday as well. And then organic matter depletion. There's two things to look at to see if how much organic matter depletion you have, at least on grassland soils, and that's the color. And so with color, there's the Munzel soil color chart, and basically you take samples from the soil and you put it behind this page out in the field and make sure the sun is over your shoulder, and you take off your sunglasses anyway, and then you match which color it's closest to on this chart here. And that's a really pretty accurate way of getting at the color, and I'll show you here in a minute what you compare that to. And then structure. Oh, and I forgot to mention on color, in the official series description, which I'll show you here in a minute, there's a moist color and a dry color, and I would recommend that you compare to both of those if you can. If you have a dry sample, compare to that dry color, and then moisten it, and then compare to the moist color, because sometimes you'll get a departure on the dry color that you won't see on the moist color. Then structure is really important, and I would say on probably 90% of grassland soils, you should probably have granular structure in that surface layer. And so if you're not seeing granular structure, definitely refer back to the official series description, because it could be different. It could have a different inherent structure, but check it against that and see if you have something different than what should be there. And then there's other structures there that as you move down in the profile, you typically will go to kind of a subangular blocky structure. Within that lower horizons, you might see a prismatic structure that goes through several horizons. That's a good thing. That's typical in a well-developed soil. You probably don't want to see the platy structure that's shown there, and that's right here, or this single grain or massive structure, unless it's just like sandbox sand. You might have single grain, but massive structure is something you don't want to see, and you probably don't want to see even like the blocky up at the surface in a lot of your grassland soils. And then compaction, and this one is, you can dig a hand soil pit and then cut a profile off the side of the pit and lay it down, and you can see compaction pretty easily. You can tell if you've got layers that basically you're looking for horizontal layers, or you might look at the rooting characteristics. Are you seeing J roots? Oh yeah, thanks, Bianca. Yeah, your granular structure is kind of like cottage cheese, like she said there, compared to just a solid mass. And anyway, thanks for that. And in the old soil surveys, they used to call it crumb structure. Gives you I like that description better, but granular works too. And something I wanted to mention too, now that you kind of reminded me, Bianca, is granular versus blocky or subangular blocky. It's not so much about the shape. If you looked at those, I might just jump back there just so you can see it. If you look at the shape of these little granules compared to the shape of that subangular blocky, they're pretty much the same shape, but it's kind of about the size. So in the field sampling guide, it says basically granular is roughly a 1/4 inch or smaller, and blocky is, you know, larger than a 1/4 inch in diameter. So keep that in mind when you're looking at structure. Oops, one too many. So kind of looking at the tools to do a field soil health assessment on grassland. They're pretty simple tools for the most part. You don't need a lot of fancy stuff. An infiltration kit is a really good tool, and it's pretty simple to use. And many times when we have events in the surrounding states here in South Dakota as well, we will give out these infiltration kits. And basically, it's a 6-inch aluminum ring. We also make them with steel, but 6-inch aluminum ring, and it's about 5.5 inches long, 6 inches in diameter. And then you pound that into the ground, so there's about 2 inches remaining above ground. Then you put in that cup that comes with the kit. If you fill it up to the first lip there, that's 444 milliliters, which in a 6-inch ring is exactly 1 inch of water. And then you time it. And the first inch of water, like I said yesterday, is to pre-wet the soil. The second inch is what we time to see how well that soil is doing. And then a shovel. I mean, there's obviously some other things you can use out in the field, but those are kind of the two. If you have those two in hand, that's going to really get you a long ways. Another tool that I use a lot, it's probably my 3rd favorite app, and that's SoilWeb for GMaps. And that's the website for that. So SoilWeb for GMaps is actually a web app. It's not a phone app, but so it can be used in any browser, either on a computer or on your smartphone. But when you load it onto your browser on your smartphone, it acts just like a phone app. It's just really slick and works really well. This is how you can get to that official series description that I talked about a minute ago and find out what those colors and structure should be for the soil that you're on. And so I'm just going to kind of go through a number of slides here to show you kind of how that works. If you can't type in or take a picture of maybe do that, take a picture of the website or whatever, but just do a search in any browser for SoilWeb for GMaps and it'll pop up. So when you first load this, one of the first things probably is you'll have to enable access locations on your browser. But when you first load it up, you're going to see this screen on the left. It's going to have this welcome screen here with an OK box. You can just click on OK. If you don't want to see that screen again, just check the box and then click on OK. And then the next screen you'll see is a map. It may be a map somewhere in California, but all you do is you click on this little target right here, and it's going to find you out on the landscape, and it's going to pull up this balloon, and you can just close that balloon, and it's going to show you where you are on the landscape. Then the next thing you can do is click anywhere in any of these polygons, just click on them, and it'll bring up a list of all the major and minor soil components for that map unit. And then if you read below there, it says geomorphic position. Yeah, and it says hill slope or back slope. Well, what does that mean? This is a real handy little feature if you're out on a landscape and you're not sure, well, which one of these soils do I pick? There's this thing called the hill slope model. And this hill slope model, basically, that's it right there. I mean, you can see it, the very top pointy part of the landscape. It doesn't matter how steep or how tall these hills are. It really works on any kind of hilly landscape, somewhat hilly. And the summit is the very top. When you come off that summit is the shoulder. Most of the rest of that is the back slope, and then it might talk about a foot slope or a toe slope towards the bottom. So with that, you can kind of determine maybe which ones you'd look at, and then you click on that hyperlinked name, and it'll bring up a profile. Then you can read the description and see if it matches the soil that you're looking at on the ground. Now, what's interesting, I didn't know this till recently, is it actually takes the Munsell soil color values from the series description, and depicts them pretty closely here in this profile. So those colors are actually pretty close to what the soil should look like. And then after you do that, you just you click on that. Oops, okay. Why is it? Oh, there it is. Sorry. Up here in the upper right, you see this word, this linked word description. You click on that, and then it takes you to the official series description. Now within there, and the print might be pretty small, but within there under this typical pedon, you'll see the A1 horizon or whatever is that first horizon. That's your surface. It'll have a color. There's 10YR21 and 10YR31. Now this first color is the moist color and the second color is the dry color. And as I mentioned before, if you have a chance of seeing the soil dry, do compare it to that dry value and then moisten it and compare it to the moist value. Right after the color, it's going to have a description of the structure in that soil, what it should be or what typically is for that soil. And here you see it says moderate granular structure. So again, like I mentioned, that's typical for a grassland. Now you can click on the close button here. It'll take you back to that profile. And there's another feature here that's pretty cool. And that's this land classification. So if you do click this on the land classification, there's a drop down list. And right at the bottom, it says Loamy Hills. That's a link directly to the ecological site description. So it takes you to this site edit that I mentioned yesterday too. And edit is where all the ecological site descriptions are housed. Now, where you're out in the country, this may not be populated yet. It's becoming more and more populated across the country, and you should see it coming to your neighborhood soon if it's not already there. Once you get to that ecological site description general page, then if you click on the sections button right there, it'll list all the sections of the ecological site. And the one you want to normally use for doing an assessment is called the reference sheet right here. You click on that and it'll bring up the reference sheet. This is the top of the reference sheet there. And then this is the first 4 indicators on the rangeland health assessment. If you page down, you'll get to the soil surface resistance to erosion indicator, which is aggregate stability. And it'll tell you the value using that Horonata kit, what value it should be for that ecological site. So you can compare to that. And then you can click on the back button on your browser. It'll take you back to the sections, or you can click on sections, I guess, right there. Take you back here. If you want to look at what the plant community should look like on that site, click on ecological dynamics. It'll take you to there, and then you page down all the way to the bottom of this section. There's actually going to be a reference plant community there with the species that should be there. And then each one of those species is hyperlinked to the plants database where you can get more information on those. So pretty cool stuff. All right, so I wanted to talk a little bit about, what kind of management, is effective in building soil health. So I'm going to run through just, I don't know, 5 or 6 more slides, I think, and just show, first of all, from a science standpoint, some cited research papers, what kind of management is effective in building soil health. So this particular study, they compared multi-paddock rotational grazing to season-long grazing. What they found was with the multi-paddock rotational grazing, there was improved aggregate stability, reduced compaction, increased soil organic matter, and increased infiltration. And I was just looking, tall grass prairie. Okay, I don't know exactly where that study was done. This is another study. This is looking at soil organic carbon beneath croplands in North Dakota, prairie pothole region. And this was comparing established grasslands to cropland. And what they found was on the established grasslands, considerably higher soil organic carbon. This was looking at, this is 2 different studies that I found very interesting. And one of them was in North Dakota, and I'm not sure, I know the author on the second paper, she's from South Dakota, but I don't remember exactly where the study was. But what they found is, and this goes to that question that was in the chat yesterday during my session, that non-native species can have a pretty dramatic impact on the soil microbial community. And different invasive species have different impacts. So like, for instance, smooth brome. In this first study, what they did is they had a site that had been dominated by smooth brome. And for quite a few years, they killed the smooth brome and they took all the roots out of the soil. Then they took the soil into the greenhouse and they planted native warm season grass seed in that soil, and the seed wouldn't even germinate. And so these plants have an impact on the soil. They alter the soil, obviously like weeds normally do. They alter the soil to make it better for themselves. But these invasive species actually have pretty significant impacts on the mycorrhizal fungi, the bacteria, and even archaea in the soil. And so that's kind of what these two studies were looking at, is not only microbial species, but in that second study, it also impacts soil nutrients, and that's another paper I looked at talks about that as well. So we're looking at soil organic matter and microbial community being impacted by non-native species. All right, so I threw in just a couple case studies real quick here to kind of demonstrate again what kind of management can lead to good soil health. I showed this yesterday as well, but this is one of our dynamic soil property study sites, and on the left is continuous season-long grazed. We were out there in October one year, and I mean, like every time I drive by, there's livestock in that pasture on the left. It's the plant community is 93% invasive cool season grasses, quackgrass, Kentucky bluegrass, and just a couple other species. And very low production. On the right is moderately stocked rotational grazed. It's actually the exact opposite. It's 93% native species, big bluestem, Indian grass, porcupine grass, prairie dropseed, and slender wheatgrass, a whole bunch of different species. And only 7% non-native species like smooth brome and Kentucky bluegrass. And so what we did is we did a dynamic soil property study, basically comparing. It's the same soil across the fence, and we do the same tests on there. I'm just going to show you a couple things that we saw. These are the soil profiles. On the left, you can see the color is quite a bit lighter in that soil. So it's pretty obvious that there's less soil organic matter, much darker over here. The other thing that we noticed is the structure, and the structure up here at the top was platy and blocky. And over here, the top 8 inches or better, it was nice and granular and fluffy and easy and fun to work with. Really like something you'd want in your garden, you know. And then infiltration, so this is the opposite of what I showed yesterday. Instead of inches per hour, this is actually the elapsed time. So like I said, we put an inch of water on to kind of pre-wet the soil, and then we put a second inch on to measure, and that's when we measure how long it takes for that second inch to soak in. And so on the continuous season long grazed pasture, it took 109 minutes for that second inch to soak in. On the right-hand side, the rotationally grazed, it only took 12 minutes for that second inch to soak in. So pretty big impact there. This is another, I think the last case study I have, just wanted to show you. And this is another dynamic soil property study site. So on the picture on the left, this area in the foreground, this is was the neighbor of the guy that we worked with here. And this was continuous season-long grazed for as long as Jim, that's the guy on the other side over here, Jim, for as long as he could remember, this has been continuous season-long grazed. It was primarily dominated by blue grama, sand dropseed, Kentucky bluegrass, a lot of short grasses, pretty low production. On the other side of the fence over here, it was a very diverse, productive community, lots of different grasses, big bluestem, green needlegrass, western wheatgrass, really very diverse community. And then 9 months before we took these pictures, just 9 months prior to this, they converted this grassland on this side of the fence to cropland. They decided they weren't making enough money on this short grass, I guess, so they converted it to cropland. So you can see the corn stalks. This is after harvest, and you can see our infiltration ring there. So here's the results of what we found. Looking at this, and I only show infiltration, but we have information on organic matter and stuff too as well. So on this this grazing stick here represents the fence line. You can see the deeper, darker colors on that rotationally grazed, very diverse rangeland over there. Right across the fence, you can see the colors aren't as dark or as deep on that grassland that had been continuous season-long grazed for many, many years. And then look this is the surprising thing. On that cropland, this is just 9 months prior, had been converted to cropland. Look at the difference in the color in that soil. And then look at the infiltration. For the rotationally grazed, it took less than 5 minutes actually for that second inch to soak in. On the continuous season long grazed, it took 29 minutes. And on the cropland, it took two full hours for that second inch to soak in. So with that, I think we got a few minutes here. Bianca, I'll let you take it away here. If you're still there. Bianca? I guess I could do it too. So just go ahead and talk about anything. What did you learn about assessing soil maybe that's relevant to you? And I don't see any extra points in the chat. I'm going to see if there's any questions there I could answer. When would you use one of these in-field assessments? And how would you, what would you learn, or how will you use what you've learned in your action plan, and what key messages may particularly inspire an aha moment with those you work with? Those are the questions that that Bianca put on here. I'm open to anybody who wants to come off mute and ask a question.
This is Theron Vernon with Palmer Land Conservancy. Not so much a question, but just kind of a discussion point. It kind of occurs to me as I'm thinking through this, that regardless of the condition of the soil, these tests are great. Like, we work in conservation easements, so at the establishment of an easement, it's great to have this, these kits out on the field, because then after the easement is established, you can then track, especially as an easement is restricting rights by nature. So there's going to be creative ways of having an operation work to see how management passes down through the grantor and then even successive landowners. And you kind of have a baseline with what you guys at the NRCS have established in these toolkits, whether they are changing operations, which is what we'd like to go to more rotational or AMP. But if they're just kind of doing continuous, to kind of see how the conditions have changed, it's almost like a baseline report.
Yeah, well, I was so glad when I heard your voice, because I thought maybe I lost total audio there. Nobody was saying anything. So, no, that's totally true. When a producer sees the water sitting in that ring, and then you're looking at your stopwatch for 10, 15, 20 minutes or whatever, or they see it soak in really fast. I mean, that's impressive, and measuring that over time or comparing it to a known value, those are all good things to do, and it's something you can do right in the field and get a instant feedback.